In this video, we'll show how to solve a particularly difficult trig integral, which is secant cubed. Now for this particular integral, neither u equals tangent x, that won't work, and u equals secant x, that will also not work. And in fact, all kinds of other things that you might try, like for example changing it to 1 over cosine cubed, none of those will lead anywhere. It's a very tricky one. So here is the trick that works to solve this integral. First of all, we'll take what looks like a relatively anti-intuitive step of just expressing secant cubed as 1/2 secant cubed plus 1/2 secant cubed. And again, at first blush, it may not be clear at all. Why would we take that step? Then what we're going to do, leave the first one as just secant cubed, but in the second one, what we're going to do is apply the Pythagorean identity to 2 powers of the secant. So what we're going to get is secant x times 1 plus tangent squared x. And now we're going to regroup so that over here we're going to put together in one parentheses the secant cubed x plus the secant x times tangent squared x. And then separately we'll just have the last 1/2 secant x over on the side here. Now what's interesting about this is that what's in this parenthesis right here is actually a derivative. It's the derivative of secant x times tangent x, or the second derivative of secant. In fact, if you take this derivative, you can verify for yourself using the product rule that what you get is secant cubed x plus secant x times tangent squared x. And so the antiderivative of what is in that parenthesis is just secant x tangent x. And then that just leaves us to find the antiderivative of secant x, which we already know is log of tangent x plus secant x plus c. And that entire expression is the antiderivative of the secant cubed.